Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects, titled YSGGA-Driven Cluster Head Selection, coupled with RLE data compression for optimizing WSN longevity. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today we will demonstrate you one of the applications that we have designed for energy efficient protocols in wireless sensor network. This is for the research purpose and even further modifications are still possible. Before moving to the video, let's talk about that what we will cover into this video. In this video, we will initially discuss about the application areas in which these energy efficient protocols can be used and these sensor networks are utilized these days. Secondly, we will discuss that whatever the code we have designed, how to execute it, what files we have to run, and what are the software requirements for it. Along with that, we will discuss about the current work done in this particular scenario and problems into that, and what are the proposed method that we have designed in this code. Finally, an overview to the outcomes after the experimental simulation will be discussed and given in details. So let's start with the application areas. The wireless sensor network are basically sensor network based communication or getting the data from the remote locations through the sensors. So it can be in the different domains. It can be used and is actually used in the agricultures at the remote locations where easily the people cannot be reached, smart cities, security and the surveillance purpose, for the healthcare as WBAN is one of the application which is using the sensors, industrial applications and many others. So the main challenge in this is basically because sensors are restricted to the power, means battery in that. So we need to reduce the power consumption with them and to get the data in a precise way. So for that, energy efficient clustering protocols are there. So inspired from that, we have designed the proposed algorithm. So let's start that how the code is to be executed. The folder that we are going to give you will have the folder name code, under which there are a number of files that we are using. Along with that, we must have the MATLAB software with us. So the MATLAB version that I am using here is MATLAB 2019A. So you can use 2018, 19 or above. Make sure the MATLAB version should be full. So you just need to copy this path from the folder where the code is there and then go to the MATLAB and paste it here. When you press enter, you will see all the files in that particular folder will be shown here in the current folder. And here there are two main files. One is the main code and one is the comparison code. So there you need to select the main code and editor window should be selected over here and there is a run button. So whenever you will click on the run button, the code will start executing. As you can see, I'm just clicking on the run button and it start executing. Here you can see the communication rounds are happening. Now let's discuss that what exactly the problem is and what exactly we have done. So we have considered this base paper in which energy efficient clustering routing protocol was given in the wireless sensor network by using yellow saddle goldfish algorithm. So they have used the yellow saddle goldfish algorithm for selection of the cluster head and then did the communication and get the results. So the problem that we have highlighted into this was that in the sensor networks, basically in different areas, the data is not where the data is not majorly varied, or the data that we need to send must is numerical or the string one. So that data can be handled in order to reduce the packet size. So secondly, the algorithm that they are using is YSGA, which is an algorithm proposed in 2018. So until it is much better with respect to the other existing optimization algorithm, like still it has the scope of improvement. So after reviewing the yellow saddle goldfish algorithm, we came to know that yellow saddle goldfish algorithm has the issues with the exploration. So inspired from that, what we did, we have improved the yellow saddle goldfish algorithm by proposing our method. Now what exactly the proposed method is? So in the proposed method, what we have done, initially we have applied one encoding scheme. Encoding scheme which is encoding the data in the lossless manner so that the data cannot be lost and cannot be degraded. Secondly, the YSGA is improved by introducing the concept of genetic algorithms mutation factor. So by using these two modifications, we have proposed the algorithm. Here you can see initially we have applied RLE encoding. So data is generated randomly. These are the factors that we have taken from the base paper in order to show that our proposed method is better with respect to their existing system. Then the data compression is applied by applying the RLE encoding scheme, which is a lossless compression technique. So packet count get reduced. So you can see, as I have already run the code, so the new packet size, the length of the new packet size is, it is around 100. From 4000 it comes to 100. Sorry, not 100. I just need to check the this is for all the nodes. So let's see, we do have the values variable, these are value, and if we will check the mean value, you can see it is around 2000 packets. So around 50% of the compression is there. Then all the energy model is described. Further, YSGA is used in order to select the best cluster head in which different parameters has been used. In the YSGA, we have improved it by embedding the GA mutation. So here you can see the proposed YSGA model is having the upgradation in itself by applying the genetic algorithms mutation factor. So this is the mutation factor that we have applied. So when we are running this code, every time initially the nodes are evaluated in terms of how many nodes are dead, when the first node is dead, when half node is, all nodes are dead. So all these factors are evaluated in every round. Along with that, the distance and other related factors which we have used for the proposed method are taken. Here we have chosen the three different, two distances and one delay along with the nodes energy, and on the weight basis we have calculated the best cluster head. So once the best cluster head is selected, later on the communication is done between node to cluster head and cluster head to sync. As the packet size is already reduced, though it is by obvious, and there are chances that our system will be more effective in terms of preserving the energy. So the results that we have attained after running this code, you can see here, this is the network that we are using in it. Then this is the curve of dead nodes with respect to the communication rounds. This is the alive node which is reciprocal to the dead nodes, and this is the residual energy, the depletion of the energy after every round. And finally this is the throughput, that how many packets are reached to the sink. These are the graphs for when the first node was dead, when 25% nodes were dead, 50% nodes were dead, and 100% nodes were dead. Now we are comparing it with the existing technique which we have taken directly from the base paper. As you can see, the graphs are already given here. So we have chosen this. So when I am running this code, the compare code, the results that we have already run were saved and are compared here in terms of different parameters as per of the paper. So it will take few seconds to show the results where the proposed method, normal YSGA, and the previous methods are compared. So you can see in every scenario, the blue color, which is YSGGA-RLE, means YSGA with GA and RLE encoding, our system is having the highest curve in surviving. Here you can see the throughput is high, energy consumption, residual energy curve is more, alive node is for longer period, dead nodes are for longer period. This show the effectiveness of the proposed method. So further modifications are still possible, which can be used in implementing the sensor network areas in different domains, either in the smart agriculture, smart cities, IoT networks, and many others. So for more details, you can contact us directly and can have the details. Thank you.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, We offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.